Normalization. One of the more difficult things to do in the land of databases is design a proper data model. That is, design the structure of your database to support your data in a way that will increase data integrity, reduce data redundancy, and improve performance and manageability down the road. So in this nugget, we're going to take a look at normalization, talk about the benefits of it, the pitfalls of an unnormalized database, and we'll cover the 3 normal forms, the most popular normal forms. And these are just a set of rules and guidelines that if you follow them correctly, you will have a properly designed database. Let's jump in. So normalization is really just a set of rules, known as normal forms, for properly designing your data model. So the whole idea behind normalization is this. We want to take big tables. Let's say we're designing a database, we have all these data points to track, and we just throw that all inside of an Excel spreadsheet. So we've got customers, their orders, and the products they ordered all living inside of one table. That's going to give us a lot of problems down the road. We're going to talk about insert, update, and delete anomalies as we go here, as well as all these other data integrity issues. But the whole idea is we want to break them down so that we have a table that is small and focused on its specific attributes. Right? So let's say that this table stores customers, products, and order information. We want to break that down so we just have a customer table, a product table, and an order table. So they only store their specific information, and then we relate them together. That's the entire idea behind normalization. Break a big table down into small tables, and then relate them together. Here are just a few benefits of normalization. Improved data integrity being a big one here. There's not going to be any redundant data with normalization. Without it, we're going to have redundant data all over the place, which is just a can of worms when it comes to managing that data. I'll give you some examples of that as we go here. Also, because we're not dealing with redundancies, our database is going to take up less space, which is always a good thing. It's also going to result in better performance and fewer indexes. These come hand in hand here. If we have a huge honking table, we're going to be indexing many of the common fields that are searched upon, which is going to be most of them, meaning we're going to have more indexes, which is going to be a nightmare because we're going to have a lot more people hitting this table and a lot more to manage, and essentially it's going to really slow down that table. Less management. An unnormalized database is incredibly difficult to manage because now we're dealing with extremely large tables with lots of indexes, with potentially a lot of data integrity issues, and a lot of data modification anomalies. If we have data all over the place, that same information all over the place, if we change one, the ripple effect needs to take place, right? We're going to need to change it in all the other places. So we want to make sure that we only store a piece of information in one spot. And we can still reference it from many places, but the actual value will be stored in one spot. So if we ever need to change it, we change it in one spot, and all the references automatically get those changes. And essentially, normalizing your database is going to result in much fewer headaches down the road. So we're going to focus on the first 3 normal forms. There are more than that, but 3 is what everybody strives for, because anything more than that is really specialized database design and often overkill for most database designs. Let's take a look at first normal form. The rule of first normal form states that we need to eliminate repeating groups of data or repeating columns. Let's say that we wanted to design a database to track learners and the certifications that they have acquired. Here's our first crack at it, and there's all kinds of things wrong with this table, but it is in 0 normal form. And the reason being is because we have both of these problems. We have repeating groups of data right here and repeating columns right here. And I've seen both of these designs in the wild, and I can tell you from experience, they are no fun at all to work with. Let's take a look at our first column here, which is repeating groups of data. This is a big problem for a number of reasons. The first one is that it's going to be very difficult for our query writers and our developers or anybody writing queries against this table to pull out specific information. They're going to have to do a lot of string parsing to get what they're looking for. This also has a lot of redundancies in it, right? We've got certifications listed multiple times, and that's known as an update anomaly. Because if we need to update a certification, maybe the name changed or something, now we have to touch it in multiple places. Our second problem here is repeating columns. This is another really bad design decision, because what happens if we have 4 certifications? Or 5 certifications? What if a user has 10 certifications? Now we have to go add a column for each one of those, and it's just a nightmare because we're going to have to continually manage this down the road. And if we do change the schema, which you want to do as little as possible, now we have to go and figure out all of the queries out there, queries that users are storing inside of their spreadsheets, to developers storing inside of their applications, to ourselves going to have to touch every stored procedure and view that touches this table. It's going to require a lot of rework. It's going to have a crazy ripple effect outside of it. So this is not something we want to do. Plus, not to mention, we have data redundancies all over the place. Again, we'll have an update anomaly here because if we need to update one of the titles, now we have to go and touch them everywhere. So here's this table rewritten to satisfy first normal form. So it satisfies first normal form because we have no common delimited data, and we do not have multiple columns to represent a single column. Now we have a single certification column. This is going to result in more records and more problems, but that's where second normal form is going to come into play. The second rule of first normal form is to ensure that your table has a primary key, a way to uniquely identify the records within. Our first table does not have a primary key. Our second table, if we were to give this a primary key, how could we uniquely identify the data in this table? Learner ID? Not by itself, right? Because we've got duplicate data in there. Certification ID? Not by itself, right? Because we have duplicate data in there. But the combination of learner ID and certification ID make this table unique. That's known as a composite or a concatenated key because we're utilizing more than one column to form the primary key. So first normal form is pretty straightforward, right? Remove repeating data or repeating columns and make sure that your table has a primary key. Second normal form is a little bit trickier just because of the way it's worded. But we're going to break it down and I'll walk you through the process of taking a table from first normal form to second normal form. Now, this is our table that we just looked at in our previous slide, and it's still in first normal form. Our goal is to break this down into second normal form. And the rule of second normal form states that your table must first of all be in first normal form, plus have no partial dependencies on the primary key. Now, this rule only applies to tables where you have a composite primary key. In other words, you have multiple columns, 2 or more, that make up the primary key, as we do with this table here. So what that means is if you have a table with a single column as your primary key, it's already in second normal form, and you can skip ahead to third normal form for that table. So no partial dependencies on the primary key. What that means is you need to take a look at all of your non-key columns, which in this case is every column except learner ID and certification ID, and compare them to all parts or all columns that make up the primary key. Let's do this column by column. Learner name, is that dependent on learner ID? Sure, it describes who the learner is. Is that dependent on certification ID? No, they have nothing to do with each other. So that's going to be a candidate right there to get out of this table. Date of birth, is that dependent on learner ID? Absolutely, it describes when the learner was born. What about certification ID? Not at all. So that tells us that these two belong in their own table with learner ID. What about certification name? Does that have anything to do with the learner? Nope, it has everything to do with the certification. It describes the certification. What about vendor? Nope, that has to do as well with the certification. The last one is an interesting one. What about date acquired? This is the date that the learner acquired the certification. So yes, this applies to both the learner and the certification, so it's not a partial dependency, it's a full dependency, which is what we want, meaning this table, or this column in this table, is just fine. So just by looking at this tells me that we're going to need a learner table, right, to track our learners and all their information. We're going to need a certification table to track the certification and everything about it, and then we're still going to need our learner certifications so we can associate learners with certifications and also track things that apply to both learners and certifications, like date acquired. So here's the result. Here's what second normal form looks like. We break this down into 3 tables. We have a table to track the learner. We have a table to track our certifications. And then we have a table in the middle that's going to associate learners with certifications. And we can link them together on their keys, right? Just like so. Now take a look at what that did to our data for a second. We completely deduplicated and took the redundancy right out of our data. Because we're no longer storing Bob's information 3 times. We're storing it once. We're no longer storing certifications multiple times. We're storing them once. So we have a master record for these once in their specific table. And that way, if we ever need to update anything, we just update their name. Their references aren't getting changed. He's still going to have an ID of 1, so we can still list Bob many, many times in the reference tables, but these all come back to that one record. So that gets rid of update anomalies. It also takes care of insert anomalies. And that is, what if, let's take our first normal form table for instance, what if I needed to add Tony in here? And I just wanted to track Tony. Tony hasn't acquired any certifications, but it's a user that I want in my system. Well, let's say that certification name is a required field. We can't put Tony in here without first having a certification. So that's known as an insert anomaly. And finally, it also solves delete anomalies. A delete anomaly is when you want to get rid of something, but it could affect data that you still want to keep around. For instance, let's say that John disappeared out of our system for whatever reason. We deleted John records, but we didn't want to get rid of our certifications. Now, by deleting John, if he's the only one that acquired these 3 certifications, now we have no reference to these 3 CompTIA certifications. So this also solves delete anomalies. So you can see just by breaking your tables down, and I've been saying this for a while, but small focused tables that contain only the relevant information will take you a long way in designing a proper database. Now let's move on to third normal form. Third normal form states that your design must be in first normal form and second normal form, and every column must be dependent on the entire key. Now this only applies to single key columns, and it's essentially the same thing that we saw in second normal form with composite or concatenated columns, but it only applies to single key tables. So in this case, let's take a look at our certification and take a look at vendor name. What's the problem there with vendor name? Yeah, we list it multiple times. We have an update anomaly here because if we need to change, if a vendor changes their name, we now need to update it in multiple places. So a really simple way to think of normal form is to look at the table and make sure the data makes sense. And you can compare each column to the primary key to make sure that it makes sense. That's one way of doing it. But just by looking at the data, look for redundancies. If you see redundancies, it's probably a good candidate to put into its own table, which is exactly what we're going to do here with our certification table. We're going to take vendor, put it into its own table, that way we only list each vendor once, and then we're going to pop a foreign key inside of our certification table to reference that vendor. And that's really the essence of normalization, right? Breaking your tables down as small as possible and using foreign keys to reference related data. So here is the end result of our design. We have a certification table to track certifications. We reference our vendors here, just like so. We have a learner table to track our learners. We still have our learner certification table here so we can track learners and what certifications they have acquired. And if we want to get really fancy, we can start now bringing in an exam table, and we can associate exams with certifications. We have absolutely no redundancy in this design. We've completely got rid of all of our data modification anomalies. All of these tables are small, they're focused, they'll perform very, very well. And the only tricky thing with normalization, one of the few downsides, is that your queries will get a little more complex in your from clause because you're going to need to join a lot of tables together. But this is why we leave normalization to the database designers, and we create views around these tables to simplify the schema. So to users, it'll still look like we had initially, one big table with all the data inside of it. But we know underneath the hood, it's properly designed, and we're not going to have any problems down the road. Now, if you want to get hands-on with normalization and play with it, I've SQLized all of this inside of the Virtual Nugget Lab. So head into the Virtual Nugget Lab, fire up SQL Server Management Studio, connect to your SQL Nugget machine here, and everything under our 12 normalization project contains these 3 scripts for first normal form, second normal form, and third normal form. What this will do, I'm going to fire this up and I'm going to execute it. This is going to create our tables in their specific forms inside of TestDB. So once you execute the script, just refresh your tables here, and here it is. So here's our learner certifications table in 0 normal form. This is the very first table we looked at because we have repeating groups of data and repeating columns. We also have it in first normal form. So that's that table reimagined into first normal form with just one certification column to list all those certs for users. And then your second normal form script here, let's open that up and execute it. We'll create our learner table, our learner certifications table, our certification in second normal form. It's going to basically turn this table into 3 tables. As we saw on our second slide, there was second normal form. So anytime you don't see a table with _0 normal form, that means it's already in third normal form. So learner certifications, and that's it in this case, with certification still needing to go to third normal form. So if we open up third normal form and execute it now, once we hit refresh, anything that doesn't have a normal form after it, certification, exam, learner certifications, and vendor are all broken down accordingly. And here's what I want you to do. This is a great exercise. Head in and create a brand new database diagram. Say yes to this message here. And then add anything that isn't a normal form. So certification, exam, learner certifications, and vendor. The 5 tables that we worked with there. Add these into the diagram. There we go. Let's get a little more screen real estate here. And now create the relationships using simple drag and drop. So let's find what we're looking at here. We know learner certifications and certification. We have a link there. Because we named our columns appropriately, our primary keys in all these tables, it would be very easy to just drag and drop them onto one another. And you can see the primary key table for certification ID is here, the foreign key table of certification ID in the learner certifications. And that lines up because we have the one side, hence the key here of the relationship, means we're only listing the certification once inside of here, but we're referencing it multiple times because multiple learners could have the same certification. That's the many side of the relationship. And now let's go find that learner table and let's bring that over here and let's do the same thing. Here's learner ID. Let's drag it onto there. Learner ID is the primary key in the learner table. It's the foreign key in the learner certification table. Same thing here. We're only going to list the learners once inside of our learner table, but we could have one learner have multiple certifications. So that learner will be listed many times in that table. We know the vendor is associated with the vendor ID here in the certification table. There it is. And then we know that our exam is down here with certifications as well. And there we go. And now we've just created all of the foreign keys. You can actually right click in here and hit arrange tables and it'll put them in a much nicer look. And there is our little database design right there. Once you hit save, you can give this a name. Call this relationships. And that will also save all of those constraints, the primary key and foreign key constraints that we just created. So together we just properly designed a database and put it into third normal form. In this CBT Nugget we covered normalization. We saw that normalization is simply a set of rules and guidelines to follow to properly design a database. We covered first, second, and third normal form and did so by designing a database together. I hope this has been informative for you and I'd like to thank you for viewing.